All right, guys, we are ready for round 2. This time we are actually going to have our y in the front, right? We're going to have our y up here. So when we're graphing hyperbolas, if our y comes first, then it is going to be vertical, which simply means that my hyperbola is going to open to the top and the bottom, so up and down. Here's where, at the very beginning in the introductory video, I had said watch out when you have a vertical hyperbola, blah, 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 blah. Right? When you have a vertical hyperbola, you have to watch out for your center. Your center, remember, is h comma k. It's the number that's going with the x and the number that's going with the y. So when you write your center, okay, many of us will just, like, without even thinking, we'll write, oh, it's a -1, +2. It is not a -1, +2. Okay. It is a +2, -1. Here is your h, here is your k. That's what you have to be careful of when you are graphing a vertical hyperbola. Because if you do it wrong, if you start with your center wrong the entire, well, I mean, you would still count things out properly and you would, label everything properly, but your center is going to be off. So you need to be very, 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 very careful. When graphing our a squared, remember, it's very different than ellipses. It's very different than ellipses. It's not a squared is the biggest number. It's just a squared is the first number. The way we've got it set up in that lovely little chart that is very confusing and kind of probably causes you nightmares. Our a squared is first. So a squared is 25, which gives us an a equals a 5. Remember, a counts out, it's the distance from your center to your vertex, so you use that to count out each of the vertices. Your b squared is a 36, so your b is a 6, and again, you use that to count out the distance from your center to your co-vertices. Your foci, okay, right there, c squared equals a squared plus b squared, so 20, oh, no, equals. Oh man, I'll just erase. C squared equals 25 plus 36. So C is going to be the square root of 61. And like we did with ellipses, we just want to round to the nearest tenth. Square root of 61 rounded to the nearest tenth is 7.8. Okay, go ahead and graph. You start graphing what you have. I have a center at 2, -1. 2, -1. These graphs drive me nuts because that -1 doesn't actually show up. 2, -1, and I label it. I label it as I should. It is a center. Ooh, sorry. I apologize to the smartboard for hitting the smartboard with the smartboard pen. That is how nice I am. So my center is a 2, -1. I am graphing a vertical hyperbola. So when I go and graph my vertices, I count out, I'm using the 5 right there. When I count out, because it's vertical, I'm going to go up, down. Okay, so I go up, down for my vertices. From my center, up 1, 2, 3, 4, 5. Okay, notice that I didn't, do the lovely little scallopy things, counting them out. You guys can handle that. There's one vertex there. Go back to your center and count down 5. 1, 2, 3, 4, 5. Okay, there's the other vertex. Go count out your co-vertices. You're counting left and right this time. So 1, 2, 3, 4, 5, 6 from your center is a co-vertex, and then count to the left 6. 1, 2, 3, 4, 5, 6 is the second co-vertex. Okay. Remember that your each focus goes with each vertex. So when you graph that, each focus has to go with each vertex. So I went up and down for each vertex, so I need to go up and down for each focus. It is 7.8. So I go up to the 5, 6, 7.8-ish right there. Label it with an F for my focus. I go back to my center. I count down 5, then 6, 7.8 for the second focus. Okay, so all of this very similar to ellipses. Only big difference so far is that each focus is outside of each vertex, whereas it would have been inside of each vertex or in between each vertex and center when we were dealing with ellipses. Here's the other big change now. Remember, we are going to need a rectangular box that connects two vertices and two co-vertices. Start at a vertex and then just head around the graph. I'm going to try to do a better job of, this dashed line business. I get very impatient, You're graphing, you want this to look all nice and pretty. I mean, I suppose I could go all crazy techno on you and do that. Oh, that's nice. Maybe we'll do that. That way I don't even have to worry about it. Boom. Although I don't particularly like that color. That's all right. It'll suffice. I'm going to switch back to the orange, though. So when we do this, we now have our rectangular framework, we'll call it. And then all I have to do now is I have to connect my center to, ooh, that's nice. All I did was change the color and it kept the nice big, I wonder if it will do that way. Indeed it did. Fantastic. Yes, it doesn't take much to make me happy. Here we go. You're going to be off your graph for most of this anyway. Oops. So just make your diagonal lines, sketch them. Of course, we will get the actual specific equation for the asymptotes when we go and do that. When we go and write that equation, obviously. That's when we'll get it. Makes total sense, Miss P. We're totally with you. You're not at all rambling like you normally do in class. I know, children, because I don't ramble. Everything I say is said with a purpose. We are opening up and down for these hyperbolas. Remember, your actual graph cannot cross the asymptote. Oh, no, 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 no. No, that makes me not happy. I don't want that now. There we go. Fix that one. The graph cannot cross the asymptotes. Ah, nice pen now. It does need to go and intersect with the vertex. Do it the best you can, guys, because I know that, I'm drawing this on the smart board, and it's just as hard to draw it on a pen, with a pen and paper. So do the best you can. You do not want your graphs crossing the asymptotes. You do want them intersecting the vertices, not the focus. They don't get to intersect the focus. They intersect the vertices. All right, so there's our graph in all of its glory. Let's write our asymptotes, our equations of our asymptotes. I'm sorry, I should say that properly. Remember, it's always going to be, we're going to have some framework. It's going to be a y minus our k equals plus minus. I'm going to have a fraction there. We can go to the picture of the, the graph and figure that out. And then I will have x minus the h. The center, we can actually just plug that in. The center is 2, -1. Remember, the 2 is going with the x. The -1 is going with the y. And then to graph, oh, let's highlight so you can see what I'm counting. We go from your center, highlight a little better, there we go, to the upper corner here. And all you have to do is count. You're going to count up and over. So we counted up 5 and over 6, right? And you'll notice that that's actually your A and your B. I just think it's kind of easier to remember, or not necessarily remember the formula, but just kind of remember what you're doing. You're counting your slope. So 5 over 6. That way, that formula is on the big charts on the front page of your notes, but it's kind of like, okay, A and B and X and K and H, and there's too many letters. So just count your slope. We went up 5, we went right 6. And that is second example done. Fantastic. I cannot wait for example 3. Probably because the center is 0, 0. And it'll be nice and easy.